we're going to need to identify what force did the work, and in this case, it's only the Fa of x. So the Fa of x, well, you can put the Fa here, and then you can go times d times cosine of 20, and that will give you the Fax times d. Okay, so you'll go 2.4 times 10 to the power of 2 times the distance of 8 times cosine of 20, and that should give us 1804 newtons of force. Okay, so it's not all the applied force. Now check your work if you got that one. Now we want to see the FBD for this, so you have your
What's the difference between work done to move or work done by force?
When the definition of work is a force that moved the object. Like you could be pushing this table. If it doesn't move, then the force that I applied does not make sense. Okay, so the force that is applied here, that is not the one that did the work, right? Because how did the object move? The object moved horizontally only. It only moved along the x-axis. It did not climb up 20 degrees above the horizon. So it only moved from here to here. So you're gonna just look at what force moved this object a distance along the x.
That's the one I did with my phone and got the answer.
And you got this one?
With my phone, and the calculator gave me a different answer.
Well, I'll have to check your calculator there in a second. So that's...
Is there any effect frictional force if you pull the regulator?
Yeah, if you pulled along the x, then that would be the entire force that moved the object. That would be the force that you'll use here.
So what about the code of the frictional force here? There is some impact in frictional force.
Oh, yeah, that's gonna be later on. This is just done by the pulling force. So for the first one, it's just done by the pulling force. It's not the net force, and it's not taking into account the force of friction yet. So just the force that is applied. Okay.
We say that applied force. I do by I guess, but how can I know it's an applied force?
Because you need to know the definition of work. So what's the definition of work?
Force.
Work is force that moves an object. So the object has to move, a displacement. Okay? So that force is, yes, that's the one that you're using to pull it. But look, I'm pulling this table. I'm pulling the table. I am applying a force to it. I'm getting tired. My arm's getting tired. My applied force did not move the table. So then how much work did I do? 0, right? So you could be applying this huge amount of force. If the object did not move at all, there's no displacement, you did 0 work on that object. Does that make sense? So you need to know the definition of work in order to answer questions like this. So the question is, well, the work done by the pulling force, you have to look at how did the object move? The object moved horizontally along the x-axis. That's the only motion that happened here. There's no angle. The plate moved along the x, so the distance 8 meters was moved by a force of what? Fa of x. That's it. Okay? So this is the free body diagram. Okay, now we're looking at the normal force. The best way to answer a question like this is to know your x and y components. So the normal force is in the vertical component, and you could see here Fn plus Fay is balanced by the Fg. With the x component, you got Fax, and that is balanced by the frictional force. In both the x and y component, the net force is equal to 0. Right? There, yeah, because it's is this accelerating in the vertical component? In the vertical component, there's no motion up and down, right? So there's no motion there. So we're looking at the net force, the normal force here, which is a vertical component. So the normal force in the x is Fn plus Fay equals Fg. So how do we find the Fn? Fg minus Fay. Okay, so there you go. That's the one that caused a little bit of trouble here, because you need to incorporate that you are actually somewhat lifting it along the y-axis with your Fay, right? So you go mg minus 2.4 times 10 to the power of 2 times the sine of 20 degrees. Okay, there you go. So what is the mass of this object? 85 times 9.8 minus 2.4 exponent 2 times sine of 20. And what did we get? What is the Fn? Okay, 85 times 9.8 is 833. Okay, minus and we get 82.08. So the answer is 751 newtons is the normal force.
So that's my L is Fn plus Fa is equals to Fg.
Yes, because
L is
F,
right?
well, in this case, yeah, Fn is up, Fay is up, Fg is down, and the net force is 0 in the vertical component. So really, if you were to write the entire equation here, net force in the vertical component, right, you got Fn plus Fg minus, Fay minus Fg. This is your vertical component. And we're going back to the unit in dynamics, right? It doesn't go away. So forces will always come back, and this is how you deal with it.
If F is equal to 0, must be done.
Yeah. So if this is 0, then these two is equal to Fg.
So in the equation, they say to Fy is equal to 0.
No, it doesn't have to say that. It just says that the refrigerator moves a distance of 8 meters along the horizontal. It wasn't lifted. So if there's no vertical component, then it's just, there's no up and down motion. Now, force of friction is mu F of n. So your answer to number 4 will depend on your answer to number 3, right? So since you have the mu of 0.2, you just multiply it by your Fn, which you found in question 3, and that gives you 150 newtons of frictional force. So you can see this is going to accelerate along the x, right? Now the work done by friction only, so that would be again question 5 depends on question 4. Frictional force is 150 and it traveled a distance of 8. So it's 1201 joules. Okay, you notice that I don't have to put the cosine or sine here because this is already taking that into account from previous calculations. So that's that.
So how is that on Ff times d? Oh, you need this cos theta, right?
No, you don't have, you don't do that because the force of friction is just backwards along the horizontal.
So
There's no inclined plane in this one. You're just pulling it at an angle with a rope. Okay?
so
We did a lot of these in the dynamics
no,
unit.
what I'm saying it will be what is the difference between number 1 and number 5?
Number 1 and number 5.
Yeah, I guess.
Number 5 is by the Fa of x.
So, but force of friction, right? So why didn't you use it cos theta?
Because you're looking at the Fax only. So here's your Fa, right?
Yeah.
Fa at an angle. This Fax is what moved the box. Okay? So that is at an angle of 20. So I'm looking for the Fa of x for number 1. For number 2, it's the frictional force that I'm looking for. Friction, in the x component here, there is an acceleration. So the net force along the x is not equal to 0. So if I were to actually ask you guys here, so the net force along the x, what is the formula here? It is Fax minus the frictional force, right? I could actually ask you a question 6 here. Question 6 is the net work done. How much work is done in total? Okay, so how would we do that then if we were to extend this question? Well, what's the FA of X? We did that in question 1, 1804. Frictional force, that's the backboard's friction, is 1201. Okay, so what is it? 1804 minus 1201, and you get a net force along the X of 603 newtons. So the net work done will be the net force times the distance. So we have 603 times 8, and you only did 4,824 joules of work on this refrigerator. So this is an extra question if I were to ask you.
Is that